Hello everyone. Today we're going to be solving Leetcode question 674, longest continuous increasing subsequence. This is a sliding window problem and we're given an unsorted array of integers, nums, and we're being asked to return the length of the longest continuous increasing subsequence. So to put this into other words, each of the numbers in our subsequence has to be higher than the previous one. So let's say we have 1, 3, and 5. So all of the numbers coming one after the other one is greater. So it's in increasing order. And so we cannot leave any gaps. We cannot skip over any numbers. All of our numbers have to be contiguous, or in other words, they have to be back to back. So we're looking for the longest continuous increasing subsequence. So let's go over an example. Let's go over the example we're given and try to solve this manually. Then we can, once we figure out a solution, we can go to coding it. So let's start with our example numbers. We're given 1, 3, 5, 4, and 7. So in order to find the longest increasing subsequence, let's start with the first item in our list, 1. If we were to increase our list by one more item, we would be adding 3 to our sequence. And 3 is bigger than 1, so all of the numbers in our subsequence would be increasing. So this satisfies the condition we were given in the question. And we can go on and increase the length of our list by one more, and we would be adding 5. Let's check, is 5 greater than 3? Yes, it does. And so we have a list of 3 items, and it satisfies our condition of being strictly increasing. So if you were to increase the length of our subsequence by one more item and add 4 here, well, this wouldn't satisfy the condition we're given in the question. You might ask why? Because 4 is smaller than 5, and our subsequence wouldn't be strictly increasing here. So it would be increasing up to this point, and then from 5, it would be dropping to 4. This doesn't satisfy our condition, therefore, this cannot be a valid addition to our subsequence. So the longest increasing subsequence we've found so far is of length 3, because 1, 2, and 3. So let's keep it somewhere so that we don't forget it. And so what's going to be our next step? We saw that 4 doesn't satisfy our condition, so we cannot add it to our list. And there's no point in exploring or like increasing the length of this subsequence any further, because even if we add 7, for example, this is still gonna not satisfy the condition of being strictly increasing, because this 4 is always gonna break that condition. So this means that we have to start over, and so we would have to start over from this 4 here. So let's do that and start over from 4. So we have one item list, and so if we were to add the last item at 7, it'd be a subsequence of increasing items, because 7 is greater than 4, and it'd be of length 2. Well, we're being asked the longest subsequence. Remember, this one's length was 3, and this one is 2. So since we're being asked to choose the longest one, this is going to be our answer. So I hope everything is clear up to this point. Before we get to coding, I want you to remember that once we've reached the end of the, once we've reached a point where like we cannot satisfy our condition of being in increasing order, we started over at this point. So keep that in mind. And also we kept kept a record of the longest subsequence we found so far in a variable here. So also keep that in mind before we get to coding. And let's code this. All right, let's code this up. So we're going to be starting with defining our variables. So remember that in the beginning of the video I had mentioned that this is a sliding window problem. So when we're solving sliding window problems, we usually have a left pointer and a right pointer to keep track of the indexes in our list. So that's why I'm going to start with defining my left pointer. And then we're going to get to the right pointer in a minute, but before we do that, let's also define our variable for the longest subsequence length. So that's basically the answer we're looking for, and I'm going to initialize this with 0. All right, so now we're going to write a for loop that's going to move our right pointer. And our right pointer is going to go from the beginning of the list till the end of our list. And that's why we're going to be defining the range as the length of nums. That's our array. So what this is going to do is this is keeping track of the number on our right hand side, and this is going to keep moving through the numbers in our array. And so remember, when we were solving it manually, we were just moving it one more to increase the length of our subsequence, and if it was satisfying our condition that the number that we moved to was greater than the previous number, then this was satisfying our condition, and we were saying that, okay, we found just another longer subsequence. So that's why I'm going to say, so if I'm going to write an if statement here saying if our number on the right is greater than the previous item, like the previous number in the list, then we just update our longest subsequence that we were keeping track of at the beginning of the code. So, and the way I'm going to do it is, so we're going to update it. But so what if the length we just found, the subsequence we found, is shorter than the one we found previously? Like we're going to go over multiple subsequences when we're looking for the longest one. So that's why I'm going to define this as the maximum of the either the one that we found previously or the one that we just found. So the one that we just found is right minus left plus 1. So just to clarify this portion of the code, so let's say our subsequence is 1, 3, and 5. And so how would we find the length of this? It consists of 3 elements. We can see it when we look with our eyes, but how can the computer find this out? So our right index is going to be here in the second element, 0, 1, 2, second index in the list, and our left pointer is going to be here on the 0th index. So if we deduct the left index from the right and add 1, that's going to give us the length of our subsequence. That's what this little code piece is doing. So once we figure out what the length of our new longest subsequence is, we should also consider the case that what if like the number we just stepped into is smaller than the previous one. It means that our condition is broken now, and we don't have a increasing subsequence anymore. So we would have to stop. and start over from with the number on the right. Remember, we were solving it manually. We went through 1, 3, and 5, and once we got to 4, we had to start over here because like there's no way we can find a longer subsequence if we go on. So we would have to start over right here. And what we're going to do is we're going to move our left pointer to here, where we're starting over. So that's why I'm going to say left equals right. So, and one more thing we have to code is, remember that we wrote, we're comparing our new number versus the previous item, but like the previous number. But what's the previous number? We haven't defined that yet. So the previous number is going to be, so at first we can just initialize it here, maybe minus infinity. So that's, it's going to start at minus infinity, and we have to update it every time we move our right pointer. So let's say we went from 1 to 3. So the previous item has to keep track of this number. And when we move from 3 to 5, again, it has to keep, like our previous item has to be 3. So we got to update it every time we move our right pointer. So let's do that right here. So at the end of once the loop iteration is finished, we update our previous item as the current one, and like once it gets back to the beginning of the loop, it's gonna go one more item. So so that's why I'm currently setting it to the current one. That's gonna be numbers right, and that's pretty much it. All we have to do right now is to return our answer, which is the longest subsequence length, and we're gonna call it a day. Let's run this code and see if it works. And indeed it does. So that's how you solve Leetcode question, longest continuous increasing subsequence. And if there are any questions that you'd like me to go over and solve, please let me know in the comments. And that's all for today. Thank you for watching.